Hello participants, I welcome you to micro irrigation engineering course on this particular topic, lecture 47 of standard and quality assurance of sprinkler irrigation system components. In lecture 46, we discussed about standards and quality assurance of micro irrigation system components. Now, these standards are very important to get the good quality material which can perform well in the field, and mainly agricultural equipment. These equipments are kept in the field for longer period. It passes through the atmospheric conditions, ambient condition, harsh weather. So, such material should not get deteriorated by the hot sun or solar radiation, or it should remain there as per the expected life which manufacturers claim. So, it needs to be get tested. So, here we are discussing about the polyethylene pipe which are used for conveying water in the network of irrigation system of sprinkler irrigation system. There are joints, and these are the quick coupling joints and fittings which are used for the joining the pipelines or making fittings. So, then design and operational requirement for operating the sprinkler irrigation system. So, these are also important components while we are installing the systems, and test methods for uniform distribution of water through sprinkler nozzle. This has been also covered in this particular lecture. The BIS, that is Bureau of Indian Standards for sprinkler irrigation system components. So, these are the specifications which has been meant for polyethylene pipes, which is IS 14151 1999, which is for irrigation equipment sprinkler pipes part 1. Then for quick coupled polyethylene pipes, because these pipes are of substandard length of 3 meter, 6 meter, 9 meter or 12 meter long, and so it needs to be fitted quickly. It should not take time. So, and whether they are leak proof. So, this is the standard which has been given by BIS, which is 14151 2008 for irrigation equipment sprinkler pipe part 2. And then design and operation requirement, this is the standard which has been set, that is IS 12232 approved in 1996. So, this is for rotating head sprinkler nozzles, and test methods for testing the uniformity of water distribution. This is also it is given at 12232. So, somebody wants to go in deeper about this part more detail, then these standards, BIS standard, one should check. These are available in the library. So, this test for polyethylene pipe, as I given you, this is IS 14151 1999. So, tests which are required to carry out. One is the carbon black test, which the short form we called CBC content test, and then the carbon black dispersion test, OLT test, whether pipe remain in the same it has not deformed when it is subjected to load on a particular temperature when it has been given. So, OLT test is carried out. Then other test is to find out whether it has got uniform wall thickness. So, there is a test for this, and then hydraulic characteristic curve, reversion test, this is another test which is done, tensile strength test for elongation, and then density test, melt flow rate test. So, these are the 9 tests which has been suggested for the sprinkler irrigation pipes. So, when it comes to the black carbon test, it offers excellent mechanical properties and resistance to oxidation, weathering, and it is used to assess the level of carbon content, which is important to keep the control of plastic properties. So, permissible limit, that how much there should be carbon content. So, this carbon black content, the permissible limit is given as a 2.5 plus minus 0.5%. Now, as per the suggested, this is the standard test procedure which has been set in the IAS 2530/1963. One should use this test to know how much is the carbon black content available. This is the device which is used to find out the carbon black content, and then it is calculated by using the CBC is given by W1 minus W2 divided by W3 into 100. So, the CBC content is estimated by using the expression that is given by W1 minus W2 divided by W3 into 100. W1 is the weight of residue, in gram. So, residue plus boat, and then W2 is the weight of boat in gram, and then W3 is the weight of the material in gram. So, this way one can find out how much is the black carbon content in this plastic pipe. So, this is the black carbon dispersion test is used to within the plastic to get required stability, and large agglomerates of carbon black can cause the opposite of the desired result, especially in pipe material. So, using that particular test procedure which has been specified in the manual, that can be used, and then this particular thing which you are seeing in the right side the diagram, this shows that the portion of the black carbon dispersion it is within the field of view of 1 millimeter under a 200 times magnification it has been done. So, whatever the fleek white streaks which are seen there, that is giving us the to find out the number and size of the agglomerates, which means that is in the standard way. So, means this particular CBD is the material under test shall be considered satisfactory if the specimens show a uniform background free from white streaks, and the number and size of the agglomerates are not greater than number and size of agglomerate given in this particular figure. So, this is a standard, from there actually it is compared. OLT test, as the name it says that OLT means it has a deformed from the original shape. So, OLT is a measurement to express percentage of the variation between the maximum outside diameter, that is OD, minus minimum OD divided by the nominal OD, that is outside diameter. So, ovality is estimated in percentage, that is maximum outside diameter, that is the maximum outside diameter minus minimum outside diameter divided by the rated outside diameter, that is the manufacturer give that what is the rated diameter it is available, that is design diameter, and if there is any deformation in this takes place, that deformation should be within the prescribed limit. So, this is the device, and then the procedure is stated in this IES code. So, the IES code as well as ISO code of 3162. So, for the nominal diameter of 63 millimeter in size as well as outside diameter. So, nominal tolerance is allowed, that is a plus minus 0.6 millimeter, and ovality is given as 1.5. This is the ratio you have seen, that the how the maximum diameter minus minimum outside diameter divided by the rated diameter. So, ovality is estimated here. So, this should be within 1.5, and then another one is for 75 millimeter diameter. This is the range which is given. So, this particular device is used to find out the roundness to the oval, oval means ovality of the pipe size. The reversion test is it is the it finds out the presence of moisture and volatility of the material. So, here the test procedure to find out the how much is the moisture present, and then what is the volatility of the material, it is given in this particular IES code 4985. These are the two codes which has been stated, and then the here the specimen is placed at 150 degree Celsius on a tray with the smooth surface, and this smooth surface is provided with a telecom powder, and then it is found that how much time it should take, the time taken in case the pipe of wall thickness not greater than 8.6 millimeter, then 60 minute time is given, and in case the wall thickness is greater than 8.6, then 120 minute time is given, and for 14.1 millimeter greater than 14.1 millimeter 240. So, these are the values which are prescribed for different thickness, wall thickness of the material, to find out the how much moisture and the smoothness is available in the pipeline. Wall thickness, as per this is the scheduled numbers for the pipe size or wall thickness is estimated to get uniform relationship between the design pressure and allowable stress. So, wall thickness is given by 1000 multiplied by the ratio of the pressure, that is the design pressure, divided by the allowable stress. So, this ratio multiplied by 1000 gives the wall thickness, and this is all further means the thickness is basically, you can see here, this is the in the diagram, right side diagram, this is the thickness of the pipeline. So, thickness is also prescribed for the different diameter of the pipeline, and also it is a rated pressure, how much pressure it is, it should be the stand. So, according to the pressure and stresses developed, the thickness is given. So, this is for class 2 pipeline, which is of nominal diameter of 63 millimeter. The wall thickness is in the range of minimum 2 to 2.4, that is a maximum value, and in case of class 1 pipe, which is of 75 millimeter diameter, this is also 2 to 2.4 thickness is recommended. Internal stress, internal pressure creep rupture test, means this is for evaluating the effect of long term stress on pipe material in order to prevent failure. So, this test pressure is given by the 2 times of the product of the induced stress, that is sigma I multiplied by the minimum wall thickness divided by the nominal outside diameter minus the wall thickness. So, this is nothing but the internal diameter of the pipeline. So, it is this particular. So, it is estimated that your test pressure, that is your internal pressure creep rupture test, it is estimated that is a test pressure P is given here for the when the it is been quality test it is done. The test temperature is 80 for 80 degree Celsius, the duration is of 165 hours, and then induced stresses it should be the stand 3.5, and then the type test, this should be the stand the induced pressure of 3.8. So, sample should remain intact while passing through the given temperature and pressure. So, to carry out this particular test, this is the code which has been specified, and this that is given for this particular test. Tensile test, the tensile test, it is an ability of plastic material to withstand maximum amount of tensile stress while the pipe is or material is pulled or stretched without failure. So, it is given by maximum tensile load sustained by the test specimen divided by the original cross sectional area of the specimen at breaking point. So, tensile strength at yield minimum it is given 19 megapascal, and elongation at break minimum it should be 500%, and the instrument which is used, it is UTM, that is universal test machine. Test procedure code is specified, and that is a 2530, and according to ISO this code is the 6259. So, these particular these procedures can be obtained from these codes, and then the how the the machine, the sample is kept. So, this is a test piece and the dimensions of the test piece, and when we are doing it, this is specified in this particular table, and then the how the sample is kept in the machine, and then the test means for HDB pipeline this particular. So, there is a research paper by this is L. Tori et al. They have given this they have published research paper, and this research paper is published in the International Journal of Applied Engineering Research. So, for details to carry out this particular test, one can refer this particular paper. Then density of pipe material is the another test which is carried out. So, density of a pipe sample may change due to change in the crystallinity, loss of plasticizers, absorption of solvent. So, it is important to know that density varies with the temperature. mainly because these pipes are kept in the field, it undergoes several types of the temperature. It may go in a very cold region, means the extreme cold region. So, very low temperature, and during hot summer temperature where the temperature goes more than 50 degrees Celsius. In our country itself such conditions exist. So, this density test is important from that point of view. Normally density shall vary between the 940.4 kg per cubic meter to 958.4 kg per cubic meter. It should not differ from nominal value by more than 3 kg per cubic meter. This is the standard, means this is the standard prescribed by BIS, and this is the code of BIS code which has been given, that is 2530 should be referred for making the density test. A density test it is the means your density of the polyethylene pipeline is estimated by using this expression, which where it is given, that is a mass of the specimen multiplied by the density of the butyl acetate divided by the mass specification mass of the particular sample minus the mass of the specimen in butyl acetate. So, this difference is to be divided, multiplied by 100 will give us the value of density of the polyethylene pipeline, and this value needs to be corrected. So, this correction is provided that rho b, that is your the density of butyl multiplied minus 4.5 multiplied by C. So, the value of density can be corrected. So, C refers to the percentage of the black carbon in the material. So, this way one can find out the density of the pipe material. The another test is melt flow rate. So, this test is used to determine the exact time, extrusion response time or behavior, and the temperature at which the polymer material will melt, and the test procedure is specified in this particular code, that is IES 2530/1963. The melt flow rate should vary in the means it is in the range of 0.2 to 1.1 gram, means this is the limit it has been given for 10 minutes and fall within plus minus 30% of the value declared by the manufacturer. So, this is the thing, this is the test one should follow for this test, and this is the device which is used, that is a melt flow indexer where this sample is kept. So, melt flow index it is the measure of how many grams of polymer flow through the die in 10 minutes. So, this is the device which is used, and this is computed by using the expression, that is the average weight of cut off sample multiplied by 600 divided by T, that is the time interval in second. So, this gives the MFR value. So, we discussed about the in case of your plastic pipes, those tests means this your density, melt flow rate, carbon black dispersion. We discussed about black wall thickness, we discussed about the tensile strength. So, all those tests we did it in case of pipe. So, those tests are also applicable for the quick coupled polyethylene pipes and fittings, and this is the specification for this Then other tests which are there, in addition to these 5 tests, there are other tests which are applicable in case of quick coupled polyethylene pipes. These tests are holding attachment of coupler parts, leakage test, rubber ring. So, holding attachment for the coupler, it should be strong enough to withstand the pressure 2 times the working pressure of the pipe. This is the important thing, means when we pipe it is joint. So, it should be withstand this much of pressure, which should be 2 times of the working pressure. Leakage, it is another very important component. If this leakage, when water comes in pressure, so there the pipe should not leak from the joints. So, this is important. So, this should be in a prescribed limit, and during the test pressure shall gradually increase from the 0 value to the maximum pressure, and this pressure is given for 1 hour duration, and then leakage test is conducted. The rubber ring, this is the ring which is provided to prevent leakage from the pipeline wherever we are joining the quick coupling devices. So, one pipeline means with the male and female, these 2 pipelines. So, there is a O-ring, and this O-ring is made up of a rubber, high quality rubber material. So, this is made up of a nitrile or neoprene, such type of material is used, and this should have it should pass through a specific test, and this test is carried out, and then one means it is found that means the black color performance, and then portable sore hardness, such things are being carried out at a by giving the temperature of 70 degrees centigrade, and this is kept for 7 days, and then the deformation is taken, that it should be within the 10% of the value. Then design and operational requirement of the irrigation equipment. Rotating sprinkler part 1 is specified by this particular code, and then the test for finding out the uniformity of water distribution, it is specified this particular code and given here. So, let us try to know what are the tests which are performed. So, test for rotating sprinkler. So, it is a test for resistance of the nozzle, test for resistance of hydrostatic pressure at ambient temperature, then hydrostatic pressure for high temperature, uniformity of rotation speed, then test of distribution characteristic, test of range of effective pressure. These are the tests which are used for rotating head sprinkler. So, this is the device which you are seeing, the top portion is the rotating head sprinkler, and it is mounted on the riser pipeline, and then all the tests which you see here that is carried out. Then what should be the height, what should be the nozzle height from this connection, and then there is a pressure gauge which is mounted here to find out at what is the operating pressure, the pressure this particular sprinkler nozzle it is operating. So, these nozzle the sprinkler heads, these are mounted, it could be of metal sprinklers or it can be plastic sprinklers. So, metal sprinkler threaded connections shall withstand the torque of 50 Newton meter for threads up to 25 millimeter, means for 1 inch, then we can say up to 1 inch thread, the torque should be this range, and for plastic sprinkler a torque of 100 Newton meter for threads greater than 25 millimeter without showing any sign of damage during the test. So, this is the test for the resistance. Test to hydrostatic pressure at ambient temperature. So, it is conducted to test the recommendation given by or prescribed by the manufacturer, and then this is carried out. So, it is starting from the 1/4 of the test pressure in the stages, and it goes to 100 kilopascal and holding the system pressure of for 5 seconds at each pressure gauge. For metal sprinkler, this is for the plastics. When metal sprinklers, when it is done that the maximum pressure is twice the maximum effective pressure for 10 minutes. For plastic sprinkler, it is this is twice the P max for 1 hour at ambient temperature, and no defects and leakage appear during the test. Test for resistance to hydrostatic pressure at high temperature. So, this is the means that was for the ambient temperature, normal temperature at place, but ambient means high temperature means particularly during places arid region, particularly in Rajasthan conditions the temperature goes very high. So, our sprinkler should be this stand, it should work there. So, for that particular pressure this should be tested. So, test assembly is to a hydraulic pressure source and increases from 0 to the maximum, that is a maximum potential pressure within a period of 15 seconds. Maintain P max for a period of 1 hour for metal sprinklers and for 24 hours for plastic sprinklers. So, these are the time duration which has been given for both types of sprinklers. And then the procedures are explained, other procedures are explained in these steps. Test for uniformity of rotating speed with the sprinkler mounted on a vertical riser. Operate the sprinkler at its test pressure and measure the time required for each quarter revolution separately. Means it could be of one revolution how much time it takes. So, before means if 1 quarter it is taken, and then the total observation it should be repeated for 5 revolution, then the average value should be taken, and then accordingly the as per the test value it is given, this should be compared. So, extreme deviation from the average shall not exceed plus minus 12%. Test of water distribution characteristics is done as per the specification. So, one need to find out the water application rate. This particular water application rate, it should be within the prescribed limit, and this is normally given for each sprinkler, and that should match with the infiltration capacity of the soil. So, this is H is given by the H is the water application rate in millimeter per hour is given by the volume of water collected multiplied by 10 divided by the area of the collector opening, that is your can opening area, and then multiplied by the 1 by test duration in hour. So, this will give us the water application rate in millimeter per hour. So, this we need to plot the curve for all the collector where the observations are made, and this this particular observation, it is a function of the distance of each collector and sprinkler along the placed along the radius. Test of range for effective pressure, this is the another test which is recommended. So, this test before performing this test, they keep the sprinkler immersed in water at 60 degrees Celsius for 1 hour, then operate the sprinkler for 10 minutes at the test pressure. We need to mount the sprinkler nozzle on the riser and then increase the water pressure from 0 to the pressure at which sprinkler begins to rotate steadily in one direction. Operate the sprinkler at this pressure for 2 minutes. Then we need to increase the pressure gradually and reach up to the maximum pressure. Then take the observation for once it achieved after 1 minute, then find out the values, repeat the test that is sprinkler inclined 10 inch from the vertical. So, this is at a particular angle of inclination. The sprinkler shall rotate consistently in one direction throughout the entire range between minimum and maximum effective pressure. So, we discussed about all those tests. Please refer these references, internet references about these tests. These are available in Bureau of Indian Standards and also international standard organization, that test code one should refer. And then we let us summarize this particular lecture. We discussed about the evaluation of stability, we discussed about the duration as well as performance of the sprinkler irrigation system components according to Bureau of Indian Standards specification. In the forthcoming lecture, we will discuss about solar photovoltaic system for irrigation part 1. Thank you very much.